Hello, hello. So here we are. The plan today is I actually wanted to do some coding because I want to implement Lifesteal grenade server side. Hello, Hannah. Do you want to say hello to everyone on stream? You want to say hello into the microphone? Yeah. Yes. Hello, Paul. Look, Uncle Paul's chatting. Hey, Uncle Paul says hello, Hannah. You want to say hello to Uncle Paul? Say hello, Uncle Paul, into the microphone. No. Okay. Marguerite, I need a little bit of help here. Oop, no. Gonna go with Mama. Yeah. No, Daddy's working. Hey, Paul. Decided I want to do some server coding today, so I'm going to do a little bit of lifesteal because we've got the grenades in, and basically the idea is if I implement the code, we can get some lovely lifesteal in play, and that's going to be a nice combat contribution to combat. So I'm quite excited for it. So. Yeah, basically, we're going to jump into code view, and I'm just going to figure out what looks nice here. Obviously, I think I need to zoom this in a little bit more. Maybe we do something like this. Tell me how legible that is. Like, at what point can you see? Is that fine? Can you tell what's going on here? Does it feel like we're pair programming? Yeah, it's pretty. Okay, fantastic. So, basically, what I want to do, what I'm thinking about doing, is I want to add the lifesteal effect. And to do this, we've got to track our lifesteal percentage within our combat events. To explain where the lifesteal percentage comes from, effectively every weapon type that has a lifesteal modifier has a percentage base to that modifier. And essentially, what we've got to do is we've got to store this in a combat event, and then we've got to translate that forward in two forms. The first form is when a combat event is happening instantaneously, and the second form is when a combat event is happening on our delayed tick damage. So the delayed tick damage currently applies to projectiles that hit at a later stage, and effectively by feeding this data through, so it's going to be a lot of feeding data through objects, we're going to be able to give the lifesteal quality to our grenades. Also, because we already have commands for healing the player, damaging enemies, and all of that, we should be able to do lifesteal without adding any new client-side commands. So this should be a completely server-side implementation. Also, because the lifesteal grenades already have their data, their lifesteal percentages stored client-side in the kind of data objects. Anyway, without further ado, let's jump straight into this. So the first thing I'm going to do is I'm going to grab my combat event and scheduled combat event. So if we go, I think it's here. So into a combat event, we're going to add a lifesteal percentage, and we're just going to store that as an I32 because I'm not particularly bothered about half percents, if that makes sense. Just for anyone who's confused there, an I32 is an integer type, which means it can't be decimal, so I'm not looking at like half a percent. Then again, if I ever wanted to do half percents, I'd probably still stick to the I32 and just do it out of 1,000 and treat a single digit as 0.01%. The reason there is it's a little bit more precise from a mathematics perspective. It's also a little bit easier from a network bandwidth sending bytes perspective. So yeah, lifesteal percentage there. Then we're going to go into our scheduled enemy hit, which we store in our state. So over here, you'll notice we have a, here we have a schedule hit, and then here we have a scheduled enemy hit. And over here, we'll just add a lifesteal percent. Also, if you have a keen eye, you'll notice that our scheduled enemy hit somewhat mirrors our combat event, admittedly, the combat event is storing different data because it is also, or more accurately, it's from the player's perspective. So those are kind of the two main data types that we're going to deal with. The next thing we've got to do is we've got to basically apply the status effect, the lifesteal status effect during combat to these two data types that we've just created. Sorry if I'm a little bit slow in explaining this. This is like I'm getting used to the whole talking to people while live streaming, while coding thing. It's new, but yeah, trying my best. Anyway, so we'll go into our combat class, and what we need to do is, when reading the weapon data, we want to match the lifesteal status effect. So when we go to weapon data, you'll notice here we go. We are matching the status effects of the weapon data, and we have a match for poison, and we have a match for freeze. So logically, this is where we would do a match for lifesteal. Sorry to hear that, Paul. Good luck with your call. Chat you later, buddy. Cool. So where was I before I said chatted to Paul? Here we go. So basically, we're going to extend the match statement here with lifesteal in exactly the same way that we have done before. So status effect, lifesteal. I think I did call it lifesteal, yeah. W status tick rate is, yeah, and it is the tick rate that we're dealing with the lifesteal because we're binding the lifesteal percentage to the tick rate rather than the damage. It's just kind of the two variable types that we get to play with when constructing this lifesteal effect. And yeah, I also wanted to just try capturing a little bit of coding as well, because I feel I have been more art heavy lately with the it's the tick rate. I've been a little bit more art heavy with the streams, and I just wanted to try to do a little bit of coding as well. But again, I think the art tends to be more entertaining for the general public, or for a more broad audience, if that makes sense. So anyway, so as you can see, as we've done before, we've created a temporary variable to store the lifesteal percentage. We are now matching the weapon data status effect to see if it has a unique status effect, and then if it has a lifesteal status effect and the tick rate is greater than 0, we'll set the percentage to that weapon's status tick rate. So this allows us to extract specific lifesteal data from our weapon data structures. That's all we're really doing here. But really where it helps is that when we push the combat event, so we go to events push, over here where we're storing the freeze tick rate, we can now add our lifesteal percentage. Essentially, this means that the way the system is designed is that everything's handled through these kind of combat events, and then different players, different enemies, anyone can add to these combat event stacks, and then the server processes these independently. By doing it this way, it just prevents a lot of lookup and is quite useful in keeping the speed of the server's processing in order n. And that processing speed makes a big deal when you're trying to handle a lot of concurrent players. So that's really just why we're doing it this way, what the considerations are, that sort of stuff. Cool, so the next step, let me just check my notes, because of course I have a few notes just to keep on track when you're writing code. we need to make sure that that lifesteal percentage variable is also getting fed into our scheduled events. So just do a quick. So if you know, I'm hitting, by the way, in this little tip, I'm hitting Control F on the keyboard the whole time and just searching for my, as you can see, scheduled enemy hit object. This was the object that we added the lifesteal percentage variable to. This is one of those situations where I can sound like an old fuddy-duddy, because when I was first studying programming and computer science, I remember my lecturers telling me you have to really focus on your naming conventions and how you name things. It's very important to name things consistently, and if you name things consistently, you're going to save yourself a whole bunch of trouble. And I never listened to them because I just wanted to code as quickly as possible. And in my decades-long career now of programming, I've learned that naming things properly makes a big deal. And I think this is one of those great examples of where, or how, or an example, or a kind of demonstration of that, because as you can see, I'm not really worried about where things are in this class. Everything has been named logically, so I know that within our combat class, we can deal with both our combat events and scheduled combat events, and you know, we can just jump straight to the correctly named objects, and nothing's confusing. So this is just an advantage on kind of adding new content relatively quickly. And yeah, so once we've fed that data through, we need to also make sure that we feed it through in our overarching tick process. So you'll notice if we go here, so this is our main process tick function. This is actually the function that calls all of these sub-functions every tick rate and processes the player-by-player command structures. So if we go down here, you'll notice here we are doing a do hit strain of the projectile wheel. This is to handle tick delay in projectiles without kind of doing needless lookups on all of the players. And then over here, we have to then carry forward our lifesteal percent from our object. And that's a very simple, you know, construction of the object from the stored data type, because basically what we're doing here is we're taking those scheduled events and we're constructing combat events from them, because the combat events are processed every tick and the scheduled events then are processed at a later stage, and in the moment that a scheduled event is processed, it's turned into a standard event and then just processed in the same way. This also means that we're not doing separate processing for different types, and it just keeps things, you know, nice and clean. I'm pretty happy with that. I think that is what I need to do there. Okay, so the next thing we need to do is we need to consider what is happening when we are healing a player and how that is affecting other players. So very quickly, I'm just going to check that all of these changes I've made compile, because they should. For context, I am jumping into my repo and running it. Okay. So perfect news is that everything compiles. Now, just to give a little bit of context on what we've done, all we've done is we've taken the data from the weapons, and specifically in this case, the weapon the player has equipped, and we've made this accessible inside our combat calculations. The next thing we need to do is we need to effectively write a function that is going to allow us to take all of this data and heal the... There was an ant on my microphone. That was crazy. Perks of being in Africa. I've lost my train of thought completely. So we need to create a function that's going to allow us to heal the player and broadcast this change in HP to all nearby other players, because obviously it's important that everyone within range is alerted to someone's HP changing, so that the clients can display an accurate health bar and all of these sorts of things. So effectively what we want to do is we want to create a little like heal and broadcast function, And then we probably want to keep that heal and broadcast function within our enemy actions main class, because then we can call it within enemy actions depending on, you know, whether it's a standard combat event passing through or a AoE one. Anyway, so let's construct this helper function. So first thing I'll do is I'll actually show you. So this is something I love to do when I'm working. I just collapse all my functions. So I use Sublime Text. You can collapse them with Command K1. Once a function is collapsed, you can kind of see the general structure. Again, here we have the main process function. Step towards and avoid, has line of sight. Here you can see the delay formula where we're using Chebyshev distance, but we're adding one for tick array, which I've put a few comments for. And now we can construct our new function, and I think we'll just put it over here above our kind of, you know, just at the bottom, and then we can basically call it within process. And what we want to do is we want to create a function heal layer and broadcast. So we're probably going to pass quite a few things into this. Do we have access to? Yeah, okay, so probably going to keep a lot of these. I want the server state, I want the XP table, I need the responses, and then we're probably going to pass some other stuff. So let's just get that in so long. So we can just copy it up here. So we want the server state, and let's also make this a little bit readable. So I'm going to do it like this. We'll grab that XP table, grab the responses. What else do we want? Probably healer ID and the raw amount they should be healed. That would make sense to me. So healer ID as a string and heal raw as a U32 probably, yeah. That looks like everything. So basically, this represents what we're gonna kind of need to feed in here. As you can see, we're actually just taking a lot from this parent class because everything is going to get called from process, which is also why I just expanded to get this done. Hey, what's up, James? How you doing, buddy? Yeah, coding wizard only because of the beard, right? It's actually why I wear the orange orange jersey, so everyone can see how long the beard is. But yeah, so okay, I just thought I would do some coding. It would be fun to do on stream. Haven't really focused on it enough, and it's also like, I think adding lifesteal to the game is pretty easy in terms of algorithm stuff, so I'm hopefully not going to make a lot of silly mistakes. And then I thought it would just be a nice thing to kind of show on screen. So I think the first thing we're going to do is, you know, right? In other words, if we're gonna, oh, sorry, don't need brackets in Rust. How silly of me. It's like I've been coding 2 different languages all day. Yeah, so, and hold on, I'm gonna do this just for win, just because James is watching. Check, yeah, spaces on those equals. Otherwise, he gets very upset. But basically, if the amount we would heal is 0, just leave this function, right? We don't need to do that. That makes a lot of sense. I think a lot of coding just boils down to, and I think the best way I can articulate this is there's a lot of simple stuff, and the difficulty isn't necessarily the complexity, it's remembering all the little different things. And I think a lot of programmers will attest to that. You know, it's not that the job is particularly complicated, it's that it's a lot of small amount of complexity, but just added together. And maybe in a true sense that is just complexity, but who knows. I'm not going to get too Not gonna get too philosophical here. Yeah, yeah. Okay, cool. Where was I? Sweet. We're writing this function. Cool. So let's get this show on the road. So the first thing we're gonna do, and now here we go. So we're gonna grab the max HP from the XP table. Effectively, your max HP is always the level, your HP level, until we change it. So for now, we can just grab it from the XP table like this. The only time that'll change is when we produce equipment that augments max HP, but that's quite a while away. The next thing I'm going to do is I'm going to do a saturating sub, so that's a subtraction on the max HP relative to the current HP to work out how much is missing. That is important for our calculation because we want to ensure that we don't accidentally overheal players. From there, we can work out our heal amount, which is going to be the raw heal with a little bit of min-max against the missing HP. What does that mean? Pretty simple. We're capping the amount that you get healed relative to the amount of HP that's missing, and this is a nice Rust-friendly way to do this that has quite a high degree of efficiency. So our next step is after we've worked out the amount that you actually need to get healed by. Cool. Then we work out the new HP, which is going to be the updated current HP. After we have applied the saturating add, in both situations we do the saturating add to prevent overflow. Hannah, listen to your mom. Oh, it's gonna have to keep the toilet paper out of reach then. Cool. So once we've done this, we now have to send a player heal command to the player that has been healed, right? So player heal to healed player. So in fact, I'll use this as a quick moment to show our command structure, and I'm sure if Happy Mage is watching, he'd love to see this. Funny guy. Anyway, these are our commands. As you can see, these are an enum where we can basically encode the general game's basically in-game commands. These are coming from client to server, and what I'm doing is we're going to be using effectively these player heal commands over here, where we send the heal amount and the new HP, or these puppet heal commands where we have to include the ID so that a client can know which nearby player they have to augment relative. So with that understanding in play, we know how to construct a player heal command. Obviously we constructed all of these. We're just going to go... We're just going to create a vec with 8 bytes. And then we're going to use extend from slice with the heal amount. And we're going to just 2 alley bytes it so we can deal with it left lined and then extend it. And then we're going to add the new HP, and then finally we're going to append our responses array with the healer ID. go with or default, and then we're going to push the command. We're going to make a new command where the command type is player hill. And then we're going to set the payload to the array we just created. And what I normally do, just to make this a little bit more readable, is to separate these out like that. So this makes a lot more sense. Responses, we put the ID of the person that we're healing or default, and then we push the command with our payload, which includes the heal amount and the new HP, which we calculated up here. And then we have other useful variables such as our max HP and our missing HP. And yeah, so we're slowly getting together what we need to do and get out of this function. And I think this kind of communicates the logic of what we're building. Now, the next thing we need to do is and I'm just going to put a comment here, puppet heal to nearby players. Again, and so the heal player, whatever. So what we do when we send to nearby players is I have a spatial hash set which stores all of the players in a kind of lookup grid, where whenever you are in a particular chunk and you enter or exit the chunk, the server is storing that data of which players are in that chunk. So whenever we need to update nearby players, we can simply look at the 9 chunks, so the kind of 3x3 grid of chunks around the chunk that particular player is in, and we can gather all of these surrounding players without having to A, loop through all of the players on the server, or B, kind of do tile by tile lookups, which can also be quite slow. So the hash grid limits our operations there to, you know, when there's a small amount of players, you're doing 9 lookups if there's no one in them, and then depending on the amount of players, it can adjust. But generally speaking, with a well-spaced server, you're less than like 100 operations on average. That's quite important for what you're going to see next, which is just me looping through the spatial hash set and effectively informing all of the nearby players of the change. So we use a vidus range of 48. I probably need to make that const a global const that we can just import and use everywhere. That's a little bit sloppy, but Win normally corrects me on those things, and then he'll fix it. So I think that's fine for now. So we're going to grab the bytes of the healer ID, and then we're just going to get the X pause and the Y pause. We can calculate what cells they're in. And then we can simply loop through the cells that are surrounding. So this is our cell map. So here we're grabbing the HCX, which is which spatial cell we're in, plus our, so this is just a loop from -1 to 1, which is just getting, if you can think of 0, 0 being the center in a 3x3 grid of 9 blocks, -1, -1 is your top left, and then 1, 1 is your bottom right. So it's kind of looping through that position. So this is getting the make this a little bit more readable. So it's getting the player from the cell relative to their positions, or more accurately, all of the players. And then what we're going to do is we're going to get the IDs. Okay, and then we're going to do a quick little check where is the player that we're sending to the player who has performed the action. If that's the case, we don't need to send them a command because cool. So what we're doing is if the viewer ID is equal to the healer ID, and the healer is the person who we previously have sent the player heal command to, we're not going to resend them a command. We're not going to send them a secondary puppet heal. For concept, we're using a kind of player viewer model where each player is their own autonomous entity, and then all of the players around them we call puppets because the client side is simulating their appearance there, if that makes sense. So what we're going to do is if the viewer ID is equal to this. Bye bye, Hannah. So here we are going to now get the specific. So basically, with this enclosing statement, we're grabbing all of the players that exist in that chunk, and then here we're going. Well, if one of those players is the actual player who sent the command, ignore it. Otherwise, we're going to construct a player command. Player puppet update command that's going to be broadcast to them because we're broadcasting to all of the players within range. Blech. Programming. I hope that makes sense. If anyone has a question, just ask. So here we go. So some people are going to kill me over my naming convention with VS, VX. Look, my logic is this is a helper function. These are not global variables. They're contained within scope. The reason I like to use smaller variable types when I'm writing code like this is simply because I'm kind of considering how, unreadable is the code going to be if all of these are kind of verbose variable names when they're in reality just kind of storing maths most of the time. Okay, cool. So what we're doing here is we're going to put our puppet heal command, and I'm just going to make sure I'm doing this. Just go back to our command types. I think it starts with a byte. Puppet heal. Yeah. So ID length is a U8. There's the Steam ID, heal amount. Fantastic. Okay. I'm not crazy. The good news is before we integrate this function, we can actually check and test to see if it actually works. Cool. So what we're doing here is just a kind of very general construction of a puppet heal command in terms of its bytes. And then finally, we're going to... So this time, you'll notice the entry is linked to the viewer ID rather than the heal ID because we are sending it to the surrounding puppets, not to the person who did it. And again, or default, push the command, same thing we did earlier. Set the command type. This one is a puppet heal. As you ate. Set the payload. And there you have it. I think. We'll have to see if it all compiles. Let's just pull this up a bit so I can actually see what's cooking. Oh yes, let's make this a little bit neater. So we're just going to chuck this in here, and like this, just like we did earlier. So fantastic. So as you can see, I think I might have been missing a... Yes, so I'm missing a bracket there. Cool. So I think this makes a lot of sense. We do all of our calculations. We exit out of the function early if we have to. We adjust the player's HP, we work out their new HP, we send them a command telling them about all of the changes, and then we calculate who else needs to know about these changes, and we send them commands. So the beauty is the next step is I'm just going to compile this and see that it runs. Okay, I've made a silly mistake somewhere. Okay, a few silly ones. So I think let's deal with these one at a time. I think just a couple of simple mistakes. See, this is when coding on stream becomes less entertaining. So I think the first one is this one. So command type has to look like this. So it's command type, colon, colon. The reason for that is if you look over here, it's command type of a command as command type up there. So that's semantic. I think I made the same mistake here. No, here was a little bit better. Cool. Command type puppet hill, command type play hill. Cool. Where else was it complaining? I think I left off the E on XP table. There we go. Let's just re-roll that. See how the compiler complains at me now. That's actually a good question. Am I exposing my... Okay, this explains it. So basically, I need to encapsulate the entire function in a client get mutable for the player that we're editing, which makes sense. Why it's complaining at me. Cool. So what I'm going to do here is we're going to grab player data from our state clients, and we're going to put in the ID of the healer because that is the player we're messing with. And we're going to go all the way to the bottom and just chuck all of this in here. Basically, the idea being, if there is no player with that player ID, don't heal them. I think that makes a lot of sense. Let's compile it, see what we get. Yeah, again, a lot of just small spelling mistakes. yeah, was complaining to me about this PL over here being already used, which is true because that should be PPL because it is our mutable vec from here. Hey, and it compiled. Fantastic. Okay. So, again, interestingly enough, coding taking a little bit longer than I expected. Just for some visual fun, why don't we just do this and just jump in? Now, this won't actually work yet, because I still need to wire up a few things before this will register. What I'm going to do, I'm just going to connect to the world because it is still compiling. There we go. Cool, I think we can leave it on that. I need to go to the bathroom, so I'm going to be right back. And yeah. Fancy feet. Yeah, I'm wearing copper boots. Cool, I'll be right back. Fantastic, I'm back. Okay, cool. So a few things I still have to wire before this is gonna fully work. I also probably need to go and fetch some lifesteal grenades from the bank. I'll do that. Just take a little trip to the bank. You see, we have cat bankers because Khajiit has wares if you has coin. This is very important law. Let's see. So, lifesteal grenades. I'm gonna get the AoE ones just because they're always more fun. And we'll most probably try them out on the Goblin Berserkers and then a little bit on the Lightning Slimes. But let's jump back to what we need to still finish on the server side. Even though everything we've done thus far is running, we need to ensure that it keeps running. Sweet. So we've constructed our helper function, we've constructed our data types, we've filled in the data when attacks happen. We now need to thread that through and make sure these actual that all of this that we've actually done happens, right? So I'm just thinking what I'm gonna do now. So I probably want to go into our combat events loop. So I'm just trying to think exactly where I want to be doing this, whether this is happening in combat or not. It's probably going to happen inside here. So, okay, cool. So this is where we get our enemy. And you can see here we apply primary damage, and then here we have our status applications. So this is where we apply freeze and poison. So in here, what we can effectively do is ensure that we, let's see, so here we're doing this to the enemy instance ID. So within this block, we probably want to, and it probably makes most sense to do it here. So Lifesteal, status capture, cool. So if the combat event hits and the applied damage is greater than 0 and the lifesteal percentage, remember that variable we've threaded through, is greater than 0. So, right, because obviously, it actually makes it a bit neater. Obviously, if we are in a situation where someone doesn't do any damage, they're not going to gain any life from lifesteal. Why even call? And then we could just calc this out. So we're just multiplying the lifesteal percentage by the damage, and we're doing it on U32s, because of course we are, and then we're dividing it by 100 to normalize it. Very simple integer maths here, and then I'm not putting a semicolon after this because that will then return this within this and apply it to heal from primary. So basically, the best way to think about this is a kind of embedded statement where if all those conditions are true, we are setting this to our damage multiplied by the lifesteal amount divided by 100, and because the percentage is an integer that needs to be divided by 100, this gives us the kind of, so if we do 30 damage with 10% lifesteal, this will be 3. If we do 40 damage with 10% lifesteal, this will be 4. If we do 40 damage with 20% lifesteal, this will be 8. And in all other situations, it's 0. That is our heal amount. So that's pretty useful. So I do think we need to store this data somewhere so we can apply it later. Because we've got the heal from primary. Okay, so what we're gonna do, because we just basically what I'm trying to avoid here, just to explain, is I'm trying to avoid running over the mutable borrows, where Rust is just gonna get very angry at me. And again, we use Rust because there's a lot of advantages from a memory safety perspective and that sort of stuff. So we've got our heal from primary here. This is within our mutable enemy instance. I think I can do it this way. So it might, compiler might get mad, but I'll just fix it if it is. I'm just thinking, did I do something similar up here? No, I didn't. Well, somewhat with this AoE part here, in a way. But then we're just within the... Anyway, cool. Pending heal equals some... So we're getting the enemy instances attacker ID. And then heal from primary, which we just set. So again, very simply, we are creating this optional pending heal. And then if a heal has occurred, we are setting it. I do get the impression I may need to just put this outside of this block over here. So yeah. And here's our freeze, EV damage, EV health, EV did hit. So then here, so this is before we do the AoE call. So basically we have to call this after the borrow ends. That's the key component here. We just need to make sure that someone has been healed. And then we can call our function. And this kind of should close the loop on what we've been talking about. I do still need to do the AoE handling, and I do still need to do the delayed projectile management. Check where we do damage applied. Okay, so this is our do enemy projectile hits, where we're calculating damage applied. We still need to also calculate lifesteal here. So here we're going to go, after we compute the damage, we can calculate heal from primary. If the shot did hit, and the damage applied is greater than 0, and the shot's lifesteal is greater than 0, return damage applied as a U32 times the lifesteal amount divided by 100. And we don't put a semicolon because it'll auto return, and otherwise we'll just return 0, which we'll do by not putting a semicolon internally. This is a little bit of like Rust syntactic trickery. It's just normal if statements and return statements if you really care. Like, I'm happy to break it down for anyone who has a question. But yeah. So that's enemy hit result. I think this is outside heal. And I can probably combine these broadcasts at a later stage. for a refractor. Again, the lookup costs are quite low at the moment. So okay, so I think before I do AoE, see where we're sitting at. Okay, so a few silly places. I think the first problem is a double let, which is very funny. There we go. Okay. The next problem is I'm pretty sure I'm not supposed to double 501. Yeah, that definitely is supposed to be and. Okay, let's see. So pending heal should be mutable. So this explains why it was let. I meant to type let mute, and I typed let, and then we got rid of one of the lets. It's complaining it's not mutable. And I think the last thing is some borrow checker problem. Let's see, second mutable borrow occurs 589. So the second one, I did think about this. Okay. So this is, so here we get the mutable enemy, or do we? Okay, so I think maybe what I need to do, just pull this out of here. And I think I'm supposed to do it down here. Let's just keep my notes correct. We're just gonna go mutable borrow over. So I do get the impression. Do we have access to the scope of heal from primary in this? I think we do. Okay, so that worked. To explain this to everyone watching, what you just saw is an order of operations problem. Basically, if I zoom out a little bit on the code, you can see that when inside this scope, so I can collapse the scope so you can see, inside the scope, we were calling it too early, so the borrow checker, which is basically where all of Rust's complexity comes from, still had ownership over the variable we wanted to mutate. So as long as we performed the mutation a little bit later, which ended up just being down here, we don't violate the borrow checker's principles. If you've ever played Magic the Gathering, the card game, MTGA, you will be very familiar with this. A good way of thinking about it is how the stack resolves in that game. That's kind of what's happening here. And when you think about it like that, sometimes you just need to get the ordering correct and everything piles. So rather pleased with that. Rather pleased with full compilation there. I think all we need to do now to get Lifesteal done is to adjust AoE. so, which is actually pretty easy because we've got all the complicated stuff in play. So I think I've already got an apply, yeah, so this apply AoE splash function, so we're going to edit it. So here it is. We're just going to do some edits to give the lifesteal function to this, and then we have victory. So just make this a little bit more readable. I've got the terminal block here on the side. Also obviously managing chat and the various windows such as live. Okay, great. So first things first, we want to pass in our lifesteal percentage as a variable. I think I'll keep it at I32, even though it's U32 everywhere else, it doesn't matter. I can change it later. We also want to make sure that we return the lifesteal heal in this function here. So we're going to keep this main structure, and if I'm not mistaken, I can do this, which is very cheeky. I'm returning the list and the new U32 as a tuple. So this is our main Vic, and then there's the U32 coming in. So we're just going to add a little accumulator. Call this total lifesteal. U32 equals 0. Makes sense. Whoops. There we go. So let's see when we're calculating the applied damage. So here we have applied okay, so this is finding out who we're hitting. Then for all of the targets in here, if the applied damage is greater than 0, so this is where we can put in our lifesteal status effect calcs and just make sure we know what's cooking. And then here we're gonna go what? Oh, my soul. I accidentally clicked that. Okay, there we go. So we're gonna go if our lifesteal percentage is greater than 0 and the applied damage is greater than 0. So if there's some lifesteal happening and the damage actually means we're going to get some life, we can increment our total lifesteal using a saturating add. And that's going to be the applied as a U32 multiplied by the lifesteal percentage as a U32 divided by 100. And I think I have too many brackets here. Let's see. Applied 32, yeah, that's correct. Divided by 100, cool. Yeah, then it would be semicolon. Does that need to be two lines? Fine. Okay. Sweet. So this is going to grab our lifesteal, or more accurately, this is going to increment lifesteal whenever we're doing damage that needs it. And then at the end, when we return deaths, as you'll recall, we are now returning a tuple. So now we return the tuple, and then Finally, we need to make sure that we're feeding this in correctly. So this is going to be the 2 times that we are calling it, and then that we're reading it correctly. So first things first, I think it's probably going to be the easiest way to find it. There we go, attack freeze. So here we're going to then go EB lifesteal percentage. And then play, I suppose, areas. Yeah, this is the difference. So we're grabbing our tuple. So as you recall, we return the deaths plus we return the heal, and now here, because we return the heal, we're going to go if the heal is greater than 0, we can call our heal player and broadcast with state, XP table, responses, EV attacker ID, and AoE heal. Make sense? I think it does. Okay, cool. So we're grabbing AoE heal here from the tuple. We're feeding it in here to our broadcast function, and we're also remembering to put the lifesteal percentage into the AoE call, which we updated. And then we need to make sure we're doing the same thing in the which path are we in? I think we're in the delayed projectile path. No, we're in combat events. So we need to do the same thing in the delayed projectile path. So I think I can just look for freeze tick this time. Or did I call it attack freeze both times? I did not, but what I'm looking for, I'm kind of just scanning it on the right hand side, is the next time, yeah, it's called freeze tick. Okay, so I was right the first time. So yeah, over here, we're going to insert shot.lifesteal percentage, which is the data that we included into the scheduled enemy hit at the beginning of the stream. And then we're also going to remember that we're not just getting the AoE deaths, but we are getting the AoE deaths and the AoE heal because of our tuple. And now, if the AoE heal is greater than 0, we can heal and broadcast with all of our variables. Fantastic. I think that is everything. Obviously, we're going to now compile and see how angry Rust is at me. And then, depending on the level of complaints we get from the computer, will depend how close we are to complete. I'm getting mismatched types. Okay, I think I put mute on each binding. I don't mind. It's not like I think it's gonna cause an issue. So there's my mistake. So here I'm returning just an empty vector if there's nothing. So now we just need to return a tuple with an empty vector and 0. Basically, if nothing's happening, there's going to be no lifesteal, there's going to be no deaths. Same problem here. Again, these are just small semantic issues. Fantastic, it compiled. Okay, so yeah, small semantic issues aside, everything seems like it's compiling. In theory, we have added AoE to the game. Kind of crazy. Seems wild. Hashtag coding. Okay, so now we need to test it, I guess. So we can go back here. Now, the fun thing is there are actually no client-side changes. So first thing I'm going to do is I'm going to rerun our master server and our world server so we can log in. And I'm going to talk a little bit about what we're doing here and what we're looking for. I think first thing first is I'm going to try and play on an account that's basically got a near-death character. And then what we're going to do is see if we can log in and gain some life back with one of our grenades. And if we gain life back, then we know it worked. So isn't that exciting? So here are the grenades. Oh, I love the pink fuse. That feels like it's lifesteal. And obviously, in full ceremonial honor, we must go and test this out on the lightning slimes. They have not been attacked enough. They must be dealt with. You know, how long can we live our lives allowing the lightning slimes to dominate how we feel, how we think, you know? Sometimes we must just band together against the lightning slimes. Cool. Oh my, it worked. Wow, that's awesome. Okay. So 10% life still also means if I do less than 10 damage, I'm not getting any life. Ah, there we go. 10 damage, 1 life. That is actually really great. So it rounds down on purpose because from a balance perspective, we're only giving you life if you're dealing enough damage to trigger at least an integer point gain. And yeah, if I actually hit it on 2 enemies, I should gain from the lifesteal. Fantastic. And again, with the lifesteal, the same mechanism applies, where you need to have done more than 10 damage to that individual target to gain life. So these lesser lifesteal bombs, as you can see, they're not going to be healing me absurdly, because you actually need to hit very high to gain. So it doesn't like, so if I hit a 6 and a 5 and a 4, or a 9 and a 9 and a 9 on 3 enemies, I'll actually gain no life because it's rounding down each 9 to a 0. And these are kind of the minor things that just keep this this weapon in check. Because obviously, if that wasn't the case, I'd be max HP by now. However, I'm incredibly pleased because this is exactly how I wanted these to work. Where, as you can see, we've used about 20 grenades, we've gained about 7 life, so we've been able to fight without needing food pretty consistently at, let's call it, lower DPS than your poison grenades. Yes, one, yeah. So basically, it doesn't do a cumulative heal with the AoE. It'll only trigger if I'm doing 10 damage. And again, this is because this lifesteal grenade is 10%. So the greater lifesteal grenade does 15%. So that's going to trigger on 7 damage or more for gaining 1 HP. And yeah, the light, it burns. What light? Am I losing my mind? This light? Yeah, I'm rather chuffed. And again, we can tweak the percentages, figure out exactly what's going to be the most balanced, that sort of stuff. Um, but yeah, I'm rather pleased with the Rust implementation having gone so smooth because, yeah, it can get a little bit head heavy moving those data types around. But I think as it is, Rust's compiler I just absolutely adore. I love how precise it is in correcting errors and telling us like what you need to fix. So that is really a place where I much prefer a language like Rust to even C, but even C is better than JavaScript, where I think JavaScript's compiler is very, very, very vague. Anyway, James and Win, are you guys still swinging by here? Or what's the vibe? Seeing as you guys are in chat. Okay, there, I just checked the message, leaving now. Sweet, well, I'll check you guys soon. Fantastic. I'll probably wrap this up relatively soon. I did really just want to do this lifesteal and test it all. Okay, cool. Sweet. Lol. Enjoy the international, dude. Dota's fantastic. I hope there's lots of lifesteal in the international. Then this will all be on point. Oh, something else I can also show on stream before I wrap up here is we have added, this is river fishing rod, and this is a net spot. I don't think I have the level though. I do not. So yeah, I've got to catch them all. No, I'm super chuffed with it because we've added, so you can see I've got 34 hunting there. So I'm able to catch quite a few fish now. And we've recently added cooking to the game, and I just need to remember to move the stove over there. But I think we can cook some tuna. Let's see how many of these. Do need to change the cooking menu from saying smelt to cook. So there is that. I don't think I have the level to do that. Yeah, no, I didn't have the level. That's funny. Okay. Oh, it makes sense. I haven't cooked anything, so I have like level 2 cooking. Yeah, level 2 cooking, so obviously I can't cook any of the high level fish. Okay, fantastic. Well, thanks everyone. Thanks for jumping on stream and chatting and having a good time. Shout to everyone who watched, and, you know, thanks for stopping by, and have a great day, everyone. I will most likely see you guys later.